Okay, so for the lesson today, or the tutorial, what we're going to do is focus on something that I find quite useful using Python, and that's the ability for Python to work with files. Now, again, I'm not a developer. I'm not someone who programs to build products, but this is one thing that occasionally has come up just in doing project management, helping to solve uh, small tasks or analyzing or running through lots of data files. Often what you can have is maybe you have lots of information, and typically in a lot of office spaces you might use an Excel file to manage that. The problem is with Excel is even though Excel or LibreOffice Calc or Google Sheets, they're all very powerful programs. They sort of need to operate within the constraints of the worksheet or the sheets that they're working in. But with Python, you can work directly with files, and in particular text files, including .csv, can be very easy to do. And what we're going to do now is create a very simple program that's going to run through an output of 100 text files. So what we have here is a bunch of output, and all of this output is lorem ipsum. Lorem ipsum is just blank, just random text essentially. But the line count for all of these files is different per file. And what we're going to do is we're just going to create a very simple program. It's going to let us open the files, read through the files, and then what we're going to do is just very basic, create an average count of what the average number of lines in all these files is. I do have a reference program here, but what I'm going to try to do is to quickly do this from scratch. So first off, you can have any text editor that you want. And what we're going to do is, because we're accessing many files, in order to access many files, or say a folder of files, in Python you need to first call in the package or the library called OS. So what we're first going to do is import OS, change the highlight to Python, and this is going to be using Python 3, and we'll show that in a minute. So import OS, you can see here the highlight has come up. Then what we're going to do is we can maybe prompt the user to give us input. We did this back in the longer tutorial of Java, Python, and JavaScript introduction. But to ask for some user input, we can maybe define a variable. Say this variable folder is going to equal the input that a user returns after we ask this question. Please provide the folder to sort through, something like that. Now what we do, what this will return when we run the program is it will ask for the folder, and then here if we just wanted to very quickly check it, we can just say print folder, and then we'll just save this as a line average. We'll just make this line average new. Okay, save. In our terminal, we do a quick list or ls to find that the file has indeed saved. And from here we can just run Python 3. This is how you would call it in Ubuntu or in Linux. This is Linux Mint based on Ubuntu. In Windows or Mac OS, forget if Mac OS has Python installed by default. In Windows, you would install the Python applications, the libraries, and you'd be able to run this similarly. And we want to call line average new. Okay. And then again, this is the prompt. This is what we just called here. So this is the please provide the folder to sort through. Now our folder here is this output, say, and we type in output, and it prints what we just read in. So this is showing that thus far the program's working. But let's actually try to go through and calculate some meaningful information. So what we're first going to do is going to define some variables. We're going to do a item count. Say item count equals 0. We're going to do a running count. That's going to equal 0 for now. And then we're also going to do an average. And this we're going to make 0.0. And the reason we're doing this is that way in Python you don't necessarily need to set a variable to a defined type. But if it's not set up necessarily the right way, it could potentially cause errors. So by adding 0.0 rather than just say 0, it'll know that this is like a double or a float rather than a integer, which would have non-decimals. So on our average, it's very likely that we will get a decimal value. So we want to set it up so that the variable can be read as such. Now, to iterate over the folder, or to go through the folder and read all of these files, this is all in our output folder here, see output, and there's 100 files, so 0 to 99. To run through this, what we can do is run a for loop, and what this is going to do is say for item, or you can also call file, but file sometimes has special attributes associated, so I like to call item. This could be really anything. You could just call it for z in the folder. But we're going to do for item in, and this is where we use the OS library in Python to run through the folder. We're going to do os.scan directory, scan dir. Then this is going to go through folder. Okay. This colon over here is where the for loop is going to start. So we're going for this in this. First, what we want to do is we want to start our item count. So our item count is going to start up. So we say item count plus equals 1. As a side note, Python does not have I++ syntax. Okay, so Python, if you want to do the I++ like we do in Java or lots of other languages, you have to do plus equals 1. But plus equals 1 works just as well. Plus equals 1, so that's going to start counting. So every time there's a new item, the item count's going to go up. Okay, and that's what's going to give us our item count. And remember that when you're calculating an average, what you want is, well, in this example, it'll be lines divided by items, right? So because just to give an average, we're going to need to count the total number of items, and we're going to need the total number of lines. Now, inside each file, we need to open the file again. So right now we're going through one file, one file, one file. If we said print item, which we can show here, it should return the file name. And if we said print item count, which should provide us a running count. And in fact, we can actually try this. So if we save here, we can run the program again. Again, we're looking through output, and it should give us a big long list of things unless I did something wrong. So there you go. So you can see the item count goes up to 100. We're pulling in each of these files, and we're getting the directory entry. So this is telling us what file it is. And this syntax, it doesn't look the same, but this is the way Python is reading through the folder. So using this library or this package of OS, when it does a scan directory, it reads the files like this. So there's a directory entry and it's here. Okay. Now the reason Python knows that we need to go to output is because output is a subdirectory of where this file is. You could go further down. So if you had multiple directories and other things, you could go pretty much anywhere in the operating system. But you would need to give the exact location of the directory. So if it was in Linux or something, you would probably be like home, user, documents, directory to look up, etc. because we're calling this from the same primary directory, so we're in the same directory as the subdirectory we're running through, I can just enter output, and Python will be able to say, oh, yep, here we go. I'm here, output's here, I know where to go, and I can just look up output. So that's one thing to sort of keep in mind, so that the Python file that you want to create before you can run through a folder, it needs to be in the same primary directory or the same upper level directory. You can't have output somewhere else on your file system and then not give the exact path of where to go. I hope that's clear. Now, we also said print folder, and that should still do, and it does. So you have output, that's the folder, and then all the subdirectories are printed here too. But we don't want to do just that. So for now, we'll just comment. What we're actually going to do now is we're going to read through the files. And then we can go for, say, line in item. So now we're going one step down. So this is a nested for loop, because we're going first through the directory, then through the file. Maybe we have, actually, let me just give another variable here. It's going to be line count equals 0. Okay, and we'll see in a minute why that is. But we want line count plus equal 1. And then in Python, it's kind of good, kind of not good. But the way the loops break is they have go by tabs. So if I tab in here, I'm in this loop. If I'm back one, if I'm here, let me actually just redo that to make sure the tabbing and spacing doesn't get messed up. If I'm here, then I'm in this loop. Okay, so this loop, because there's no other tabs below it, it's done. It's going to run through every line in the item or the file, and it's going to add 1 every time it comes across a new line. Then once that's done, we're going to add count plus equals line count. So our existing count for the total number of lines is 0. And now what I want to do is I want to add all the lines in every file, and I'm going to count it like this. Okay? And then the next time this runs, line count is cleared. So this is really number of lines per file or item. This is number of lines in all the files. And here is number of files in the directory. Okay, so like we just said, to get the average, we're going to divide count by item count, and that'll give us the average number of lines. So here, if we want to test again, we can print count, and it should show you a full count. We can also print item count, and we can calculate the average. And we can print the average is, and then essentially all you really need to do is this. However, one thing that Python tends to do, at least that I've run into a couple of times, it'll print an error. Actually, we can maybe try to show that error. So we'll use that. I think the logic is fine. Okay, here. Let's zoom in a bit. Run this again. Output. Traceback call. Yep, that's the error. So line 19 in module, for line in item, type error, object is not iterable. Okay, so we have a small issue. For line in item, line count plus equals 1. Why is it not iterable? Let me just check I created this code before. Okay. Yep, so what I did is I missed a step in opening the file, which is here. So that's my mistake. Let's do that now. Okay, when we scan the directory, what we're doing is we're working through the directory. But to actually read a file or to actually access a file, read or write to a file, you need to then actually tell Python, open this file. Okay, so we'll create another variable called openItem. And then what we're going to do is open item. Okay. Now, for best practices, what we should also do is because maybe you run into an item and for whatever reason the file type is not available or it can't be done in Python. It's very easy to run into errors that way. Now running it like this is good in the sense that we can see the error immediately. But if you were creating something which is actually more for other users or something that you wanted to make as like a production, one thing which would be a best practice would be we create another line down and we do a try. All of this gets tabbed over. And then we have an except. Print file of that type can't be opened. And then we exit the little program that we're running. This is a best practice. For demonstration purposes, we don't necessarily need to do this because, again, sometimes it's good to not have it so you can actually see the error while you're writing the code. But as a best practice, like for example, if it's just running through text files, this is perfectly fine. If you're running through maybe .csv or Excel or a JPEG, like an image file, then you might be able not to be able to do this. So that's why you have this try and accept, so that it would only work for the files that it can. So for this, we're going to add that in there. Open item, and I believe the syntax should be, nope, missed one thing. Then we're also going to tell open item, we're going to tell that we want read only. So we're not opening the item to then write to it. We're opening the item to read to it. Python can also write to files, which is really powerful. But for now, we're just going to read the files, get our count, and see if this can be run. Okay. And again, I expect there to be another issue with this right here, but we'll see that in just a minute. So let's rerun the program. Okay, so there are any immediate errors. File of that type can't be opened, so we're running into that error. And this is where, for debugging purposes, we can comment out this best practice here. We'll see what the error is. This item is still not iterable. Okay. I wonder if I have a bad file in this folder. Salt.txt. Oh, I know. It could be that this is open. And because one of the files is open, it doesn't like that. This is open file, open item. Oh, yep, and we didn't change this variable. Okay. So the thing about programming is it does exactly what you say, not exactly what you want. So quick little bit of debug. This is expected. I'm not super great at programming while recording at the same time, but hopefully I think that's the main issue that we need to just work out. Output. There you go. Okay, And then this is throwing a traceback call. And this is expected. So we got the folder. This is the first thing we're printing. Print folder. That's where we're getting this output. Then we have the line count. The line count is coming back. And we're printing count. Printing item count. And yeah, there's one other small issue with this program, is it printed count as 55 and it printed item count as 1. So let's see why that is. Item count, line and item. Yeah, okay. It has to do with the spacing again. So first, let's fix this error. This error says type error must be string, not float. Okay, so right now the average as it's showing is showing as a float. And I mentioned that this would throw an error, and it did. But what we can do in Python is we can take the existing value and we can change it to a string. And that's done by putting this str in front of the value. So we're telling Python that, okay, when we're printing this, we don't want to just print, we don't want to print this string plus this average variable. What we do, but Python is going to insist that in order to combine these two, we need to have the string combined, two strings combined. So we first tell that Python to turn that into a string. Don't leave it as a number, and then we can print it out. So that should solve this problem. The other problem that we had is when we're running this, we're actually running it as part of this nested for loop. We're still running this on a file by file basis, which is why it's giving us this initial output. The reason it probably didn't give us a whole bunch of output is because it hit this error. So first thing first, let's pull this back. Which is going to give us exactly what we want, in theory. So again, sometimes I wish that Python would have things like brackets, like we do in Java and C and C++, etc., but it doesn't. So you have to work with the spacing. Now what we're doing for this file is for this item, okay, so we're running through all the items. We're counting the items. We're creating a new variable called line count. This is the number of lines per file or per item. We're going to open the item. In each item, we're going to count the lines. This counts all the lines. Once this is done counting, and for clarity, we can separate this out a bit more. Once that's done counting, we then add that particular file or that particular item's sum of lines to our running count. So that count gets the number of lines per file. Then, once we've run through all of them, the for loop is done. We're going to print the count of the total number of items. We're going to print the total number of items. We're going to calculate the average of average lines per item, and we're going to print the averages, this string. Now, I think this should work. And there we go. So it counted a total of 5,589 lines across 100 items, and the average is 55.89. Now I did create this script before. We can just compare it. And output is a little bit different, but result is the same. So that should work. So again, something that's pretty simple to do. Really powerful if you do have lots of files. These could be anything like maybe data outputs. They could be survey files. They could be specific, words inside a text. You can even search, continue to go down and do things like if a string of text, maybe a lorem in line, you could have something like a lorem count. Like I'm looking for how many times this particular word, or in how many lines this particular word or phrase appears in the line. You can count like that. And I think this is one of the reasons why Python, along with a bunch of other libraries like NumPy or Panda, they come up and they have really good statistical applications. And it's really, rather straightforward to run through these files. The other thing that I just wanted to mention, we're not going to do that for now, is that what I used to actually create these 100 files was not just like copy, paste, copy, paste. Essentially, I did the same thing whereby I opened a file, I read from that file, and then I basically set up a random line of where to stop writing. So we open a read file, which is the file to be read from, which was just a bunch of lorem ipsum, like gobbledygook text, right? And then did the output into this output folder, plus a number, plus the read file. And then the write file is all of the output that was collected when we did that. I'll put this as a reference in the blog. I'll put the source code for this as well. But this just talks a little bit more about how to write the file. The one difference I do want to mention is that when we did the read file here, we highlighted that when we open it, we want to open it as read only. So we did this R. If you want to write to a file, you open it with A. And the A essentially stands for append, which means that we write our output and we keep writing output over and over and over. So if, for example, you wanted to write one line, one line, one line, one line, you would open the file, write that line, Python would close the file. The next time you need to write again, it would open and write a new line to that file. And this is the way you can just have like a running trail of output to then write to an outputted file. And doing this, you can make it so that it writes the different files, which is what I did here. So there was a variable or a number which said, okay, we're opening new files every time we're writing. But it just makes it very easy to generate lots of files. And that could be good for certain things, like say, for example, there's a bunch of maybe HTML sites. There could be maybe a bunch of text output, which is important. Maybe it's like a configuration for a system, or it's some type of data point, and you need to update all of those data points. Well, you could, again, go through a directory. For every bit of file, or every item in this directory, I need to add this line of text. You can do that in Python quite easily. So it makes it very useful and very practical. So putting all of this together, we'll clear out these because we don't need that. We'll bring back try. We'll bring back the exception, which is again best practice. Okay, and then let's go up here. And then just make sure everything's still working. We'll run last time. Yeah, this is where the spacing becomes a little bit annoying. Okay, and it gives us the same output. So this is kind of the best practice version with try and accept to make sure that you're not running into files or having a bad file sort of break the code. And then from here, you can then, maybe use this as a template, and hopefully it's as helpful for you to then go on and figure out solutions to the problems that you run into. So again, I just wanted to use this as an example of sort of practical programming with Python. And one of the most common use cases is that I play with it or leverage it to solve just everyday problems like in daily office work, even though I'm not a developer. So I hope that was helpful, and thank you very much.